This is 1973, number 29. So you kind of need to know what the graph looks like. So I'm going to approach this from just a graphical method, not really too much calculus. So here is a basic sine wave. Not very pretty, but you get the idea. So what happens when you do -1/2? Well, if you take this function and subtract 1/2, everything's going to move down 1/2. So let me erase this yellow stuff with the gold. So your maximum points, okay, so this 0 here is going to move down 1/2. So that crossing point will be at -1/2. This maximum was at 1. Now this maximum is going to be at 1/2 because you move it down 1/2. This 0 crossing point is going to be at -1/2 here. And this is totally off because this is this point here. So this was -1. Now you move it down 1/2. That's -1.5. And this pattern just repeats all the way down. So this is the graph of sine x -1/2. Now the question is, what does the absolute value do? I'm going to graph that in gold. So the absolute value takes anything that's negative and makes it positive. Well, this is negative down here, so the absolute value is going to make it positive. It's going to be right there. All of this down here is negative. So the absolute value is going to flip it up, so that point's going to be up here. You're going to get something like that. All this is negative, and you're going to get the same thing. It's going to repeat over and over and over and over and over. So your final graph is going to be, I'll do it in this color. So this pink graph is the absolute value of sine x -1/2. So clearly the maximums occur over and over and over, and that's 1.5 because it was moved down 1/2 to -1/2. So when you flip it to positive, it's 1.5 or 3/2. So that's how you do it graphically. I think that's easier than trying to do derivatives and stuff.